Before you is the star system Kepler-90, located 2,500 light-years from Earth in the constellation Draco, and this is HD 10180. It is situated in the constellation Hydra Australis, 127 light-years from the Sun. A total of 21 light-years away from us in the constellation Cassiopeia lies the star Gliese 892. What unites all these stars, you may ask? The thing is that they are all record holders for the number of exoplanets in their systems, not counting the solar system, of course. Kepler-90 has 8. HD 10, the Gliese 892 system, each have 7 confirmed exoplanets. These systems are quite interesting, and they share something in common. The inner exoplanets in these systems are located very close to their stars. In our solar system, the closest planet to the star is Mercury. Its minimum distance to the Sun is approximately 46 million kilometers, which is 0.30 astronomical units. And at aphelion, the farthest point, it is 0.46 astronomical units, which is almost 70 million kilometers. For us, this is very close, of course, but take a look at the Kepler-90 system and pay attention to the third exoplanet from the star Kepler-90I. The distance from it to its parent star is 3 times smaller than the distance from Mercury to the Sun. Meanwhile, there are still 2 exoplanets located even closer to their star in front of Kepler-90I. The closest exoplanet to the star HD 11180b is located 0.802 astronomical units away. Exoplanet HD 219134b in the Gliese 892 star system orbits at a distance 10 times closer than Mercury to the Sun. In fact, there are many exoplanets located so close to their parent stars. They have been discovered and continue to be discovered by telescopes like Hubble, Kepler, and now James Webb, among others, but these are often gas giants. Therefore, we had to work hard to find examples of rocky exoplanets located close to their stars just for you. Rocky worlds huddling close to their stars are quite common in our galaxy. As we have just seen, many systems have several exoplanets significantly larger than Earth, squeezed into orbits smaller than Mercury's. Scientists are wondering why there is such a huge gap between the Sun and Mercury. According to one theory supported by the overwhelming majority of astronomers, during the formation of a planetary system, it develops a protoplanetary disk containing the matter and substance from which the system formed. This material gradually clumps together due to gravity to form small blobs. Over time, these blobs grow larger and larger until they form planetoids with diameters ranging from 10 to 100 kilometers. Many of these objects break apart when they collide, but some continue to grow. These are the ones that become planets and moons. Since gas giants are balls of gas with liquid cores, it may seem impossible that an asteroid-like object could have formed them. The planetoids formed the cores of these gaseous planets, which became molten when enough heat was generated. In our solar system, the orbits of the planets are parallel to the rotation of the Sun. This strongly supports the theory and indicates that all the planets were formed from a single rotating disk. The culprit for Mercury being so far from the Sun, as well as the reason why the inner planets of the solar system are so small, might be the young Jupiter. According to one version, the core of Jupiter could have formed close to the Sun and then pushed through the zone of building solid planets. As young Jupiter moved along, it absorbed some material while pushing away others. As a result, the inner planets were starved. Mercury, Venus, Earth, and Mars did not receive enough raw material and remained small. Additionally, if scientists are correct in their models, our solar system is missing 4 planets that should have orbited before Venus in the past. When all collisions and absorptions by Jupiter were completed, only Mercury survived. This version explains why Mercury contains too many heavy elements and lacks lighter elements. It is possible that collisions with other cosmic objects cleared the outer light crust of the planet, exposing the dense layer beneath. This may also explain why models of the solar system show that residual material orbits around our star. For the formation of just Mercury, this is too much. The inner planets of our solar system formed from a belt of debris stretched between the current orbits of Venus and Earth. Mercury and Mars were built from material at the edges of this belt, which also explains their small sizes. Jupiter is believed to have formed significantly farther away, and created the outer edge of the belt. Everything in this theory is consistent. However, what formed the inner edge remains unclear. But let's imagine what would happen to the inner part of the solar system if a body 3 times heavier than Earth appeared within Mercury's orbit and then migrated away from the Sun. For this, there is computer modeling in the scientific community based on high-precision data. You can also try some options for this. There is a program called Universe Sandbox, which many of you have probably heard of. So after modeling, researchers found the following. If a disruptor of the solar system, let's call it that, does not move too fast or too slow, then it will clear out the inner parts of the disk and dust surrounding the young sun and leave enough material for solid planets to form. Moreover, the young Jupiter could have gathered enough debris to form a second core and push it away from the sun. This second core could have become the seed from which our Saturn grew in the future. The idea that Jupiter plowed through the inner solar system is quite plausible and is agreed upon by leading astrophysicists. However, many of our viewers enjoy critiquing everything, so let's also look for pitfalls in this version. Building a giant planetary core within the orbit of Mercury is not too difficult. Pebbles and boulders in the forming solar system likely moved inward. They could get close to the sun, where solar magnetic fields created turbulence and captured falling material. If even part of this debris clumps together, a stone ball several times more massive than Earth can form. Gravitational interactions with spiral waves in the disk surrounding the sun can push the newborn planet both inward and outward. But how quickly, how far, and in what direction the planet moves depends on properties such as the temperature and density of the disk. That's why there is still no definitive answer. By the way, there's another curious explanation for why Mercury is so far from the sun. It's related to magnetic fields. If you're interested, you can search for it on the internet, but I find it somewhat unconvincing, so I don't see the point in discussing it. Infrareal. Mercury is strange. It's the closest planet to the sun, yet it's not the hottest in the system. It's seemingly near the star, but at the same time the darkest. It's a planet, but has a huge sodium tail like a comet. However, as the classic says, those are completely different stories. Thank you.